Alrighty, hello everyone. Welcome to Lowell Observatory's interactive stargazing live stream. My name is Claire. I'm an educator here at Lowell Observatory, and I will be leading you guys throughout the night to look at different objects in the night sky. So I have a couple on the list for you tonight, but as always, if you ever have any requests of things that you'd like to look at, go ahead and put it in the YouTube chat and we'll try to get to it as soon as we can. A quick note about the night is that we do have about a quarter moon going on, so fainter objects will be slightly harder to see. And also, because we are fairly low to the horizon, some planets are fairly low to the horizon, we will unfortunately not be able to get Jupiter and Saturn tonight. However, if you have an interest of trying to view some conjunction images, Lowell Observatory did a live stream yesterday, and you can go ahead and check that out, and there's lots on the conjunction there. So to start us off, I have a galaxy called NGC 1097. So this is a barred spiral galaxy about 45 million light years away. Now this one's kind of cool because it is an interacting galaxy. So there's a little bit of a smaller galaxy that you can see towards the lower right. That is a smaller galaxy that is interacting with this bigger galaxy. That smaller galaxy is called 1097A. So these galaxies are interacting with each other. You can faintly see some of that more spiral shape coming off of that barred structure. But it's kind of interesting to see interacting galaxies in the night sky. So oftentimes these galaxies will come towards each other because they're gravitationally attracted, and then for millions of years, they'll slowly interact with each other, and we can start to track that movement, which is really cool for us to see. Wow, it already looks like we have lots of requests, so we'll go ahead and jump right into those. Let's start with Mars. So we're using what we call the PlaneWave software, using our 14-inch PlaneWave CDK telescope. So we have a camera attached there, and that's how we're taking all of these images for you guys. Now with a planet that's so bright as Mars, we are going to switch to video mode, just so we don't have quite as large of an exposure. So we're going to lower the exposure a little bit just to try to get some more details on the surface. That looks really good. So you can start to see just a little bit of the darker colors on the surface of Mars, kind of in the middle there. That darker area is caused by ancient lava flows on the surface of Mars. So that's kind of how we get the dichotomy in that color right there, which is kind of fun to see. And just this past summer, we passed the opposition for Mars as well, which was a pretty good event where it brought Mars to the brightest and closest approach to Earth. So we got some pretty good views of that. We are going to go ahead and move on. So we have someone requested the Eskimo Nebula, also known as the clown face. So we'll go ahead and go there. So this is kind of a cool one. This is a planetary nebula. And this one is so bright that we can also stay in video mode, which is kind of cool. So these planetary nebulas are interesting. Despite the name, they have nothing to do with planets. So these nebulas are caused by dying stars in the night sky, specifically stars that are about the mass of our sun. So we're starting to get it just in the center. You can kind of see a bluer dot next to that nice bright star in the center. It'll be kind of that turquoise-ish blue dot. We might be able to get it a little bit brighter. We'll see. There we go. That looks really good. So you can kind of see this nice spherical shape, kind of that gassiness compared to the stars around it. So this is all of the gas that used to comprise of a star that has just kept expanding since that star died. It was no longer to burn different elements in the center of this star, and so it became really unstable, and all of this gas just kept expanding. And this is kind of the remnant that we can see here. This one, I really like the blue color. It's really nice to look at. So I think we have another request for Pluto and Neptune. So we can go ahead and go to Neptune. The thing about Pluto is that it is so small that we won't be able to really see which one is Pluto. So the kind of the thing with this is that because it's so small and faint, it'll look like a background star. Really, the only way to understand which one is Pluto in the night sky is if we took a photograph and then took another photograph sometime later, tried to compare those photographs and see if an object moved back and forth between those two. That's actually how we discovered Pluto back in 1930 here at Lowell Observatory. So we won't really be able to get Pluto tonight just because we won't really know which one it is. So I think we can get Neptune though. We're starting to get that here. So sometimes these fainter planets out there will be a little bit harder for us to get, but it looks like we got it all right. So Neptune's our last planet, the 8th one, right there in the center. And these Neptune and Uranus together are what we call ice giant planets. So they're kind of like gas giants, but they're also kind of cold, except in the center, they get really, really hot and pressurized. So we think on some of these outer planets, you can actually have seas of diamonds. But the only thing is that also on these outer planets, the wind speeds are so incredibly high that it would basically be impossible to kind of go into that planet. Let's see. We have another one for the Crab Nebula. We should be able to get that all right. So we'll go ahead and move there. Let's see. So the Crab Nebula is a supernova remnant, which is really, really cool to us. So a supernova remnant is basically all the gas and stuff that we can see that is left over from an exploding star. Now, the thing with the supernova remnant, this one in specific, the Crab Nebula, is the remnant of a supernova observed by Chinese astronomers back in 1054. So this is the first astronomical object that we have been able to correlate to one that was observed long ago, which is really, really cool to us. So we can kind of get two different aspects of this. We can look back at the records of the Chinese astronomers and what they thought this exploding star was, and we can look towards today and what this supernova remnant looks like, and we can really understand a lot about what supernovas do, what they are, and how they interact, and kind of how they become supernovas in the first place, which is really, really cool. So this guy is about 6,500 light years away, and there's a neutron star at the very center of this nebula, which is kind of what is giving us all of that ionizing power to light up all of this gas around it. So we can kind of start to see some of those like tendril-like features. It looks kind of like an irregular type of nebula. So we can really start to see what this supernova thing does. So again, supernovas are violent explosions of stars in the night sky, and it's pretty cool that we can see some of these remnants. It really helps us understand how supernovas work. So the Crab Nebula is always a really, really cool one to look at. Let's see. Looks like we have other questions and such. So we have a question of why does the galaxy look so small compared to the stars? I think we were talking about the first galaxy that we were looking at. And the thing about this is that that galaxy was about 45 million light years away and also kind of faint. So we didn't get the actual whole galaxy in the picture just because we'd have to take a way longer exposure, and it wouldn't be very fun for you guys to sit around waiting for perhaps hours at a time for us to get a really, really nice image of that galaxy. So they can look rather small just because we haven't fully developed the image, and also because they're really far away from us. So that is something to keep in mind. Looks like we have another one for the Orion Nebula. That's always a good one to go to. We can head there. It looks like there was another question. I can answer that real quick. What's the exact time the planets aligned? So the peak of the conjunction was yesterday on December 21st. If you're interested in seeing some of the footage from that, we did a live stream yesterday, and you can always go back and check that out and kind of learn more about what the conjunction is, and also look at some pretty cool images that Lowell Observatory took as well. So here's the Orion Nebula. Now, the Orion Nebula is actually visible to the naked eye. So it's an incredibly bright nebula, and it is the closest star-forming region to us, which is really, really cool. So this is an emission nebula. It's about 1,300 light years away from us. We can see lots and lots of that gas and dust. One of my favorite areas to focus in on is actually, it looks like we have a satellite passing through that little long streak. It'll kind of be moving up towards the image as well. So that's kind of a fun thing to do and see. There's lots of satellites passing through, and we catch them in our images quite often. But just below that little satellite streak, you can see these darker patches of this gas, which is really cool to me because sometimes when we look at nebulas, they kind of look almost 2D, but these nebulas are incredibly 3D. They span thousands of light years across sometimes, and they're just full of gas. So what this nebula is doing is that over time, all of this gas will eventually become stars. So all of this hydrogen gas will kind of like do the snowball effect and create all these new stars for us to see. Now, something cool we can do is if we switch to video mode, we can start to get the cluster at the very center of this nebula called the trapezium cluster. And this was actually discovered by Galileo, this cluster. And a lot of these stars are what give us kind of like the light and power in order to see. So you can just about see 4 there, kind of down there. That is the trapezium cluster. There we go. Perfect. It's kind of a fun thing to see just because when we are looking at the bright nebula, a lot of that center stuff can become overexposed. So it's kind of fun to just take a different look without the gas and see what's really in there for the Orion Nebula. Let's see. I think someone asked for Saturn, and unfortunately Saturn has set here up in Flagstaff, so we won't be able to see Saturn tonight. The Butterfly Nebula is also not up right now, so we won't be able to do that. Another request for Lunar X and B, or Lunar 10 and whatever, and those are up at 9:30 p.m. tonight, so we won't be doing the live stream for that long, so unfortunately we also will not be able to get those. Let us go, we can head over to the Pleiades. I think we can get at least 1 or 2 stars through here. It is rather too big for the field of view, but we might be able to get at least 1 star. And the Pleiades star is always really, really pretty to look at. So if we can at least get 1, that would be nice. But keep in mind, this is an extremely wide field, or these are too wide field for the camera that we're using at the moment. So we won't be able to look at the entire cluster all at one time. So this is one we have right in the center. These stars are always really, really nice and blue. These are very young stars. And the Pleiades cluster is also known as the Seven Sisters cluster or the Subaru cluster. So if any of you out there own a Subaru car, your logo is actually the Pleiades cluster, which is kind of fun to think about. We have another one for M33. Looks like that should be good. So we'll head over there. Ooh, nice, the Pinwheel Galaxy. That'll be really fun. And someone also asked for the California Nebula. So the California is probably too faint with the moon right now, so we probably won't be able to see that tonight, unfortunately. But we can check out M33, which is a super cool galaxy to look at. This one is called the Pinwheel Galaxy as well, and it is part of our local group of galaxy. So it's us, the Milky Way, Andromeda, and M33, along with a bunch of dwarf galaxies that kind of make up our local group of galaxies. So these are the ones that are closest to us in the night sky. So we're starting to see this galaxy a little bit. We can already start to see that nice bright galactic center. We can start to see some of those spiral arms coming out, which is super cool. This is such a pretty galaxy to look at. It's a very purple galaxy. And I really like the point of view of this. We're looking at this galaxy face on, which can really give us a point of view of the extent of these galaxies and really how far reaching in the night sky they are, which is really cool. So we're starting to see those like that pinwheel shape a little bit more. And again, this galaxy is part of our local group. It's a really pretty one to look at. So that was a great one. Let's see. So Vesta is not up right now, so we won't be able to look at that. Let's see, we can try NGC 598. It looks like that one is that one should be up for us, so we'll go ahead and take a look to see what that is. 598. Let's see, we might have to do a different type of search, but no worries. So we'll go there. And someone also asked, what is the aperture of this telescope? So it is a 14-inch plane wave CDK telescope. So that's what we're using right now. And just looking for some more of these requests. Someone asked for UI Scooty. That is below the horizon at the moment, so we will not be able to look at that star. So it looks like we're trying to get NGC 598. Oh, it looks like it's the pinwheel. Okay, so that sounds good. So we just got that done. As we wait for more requests, we can go to one that I really like. We can head over to the Running Man Nebula, which is also in the constellation of Orion. It is pretty fun to look at. So the Running Man Nebula is kind of what it's supposed to sound like. It's a nebula that's supposed to look like a running man. Now, sometimes in astronomy, astronomers name some things that perhaps they think looks like something, but to the rest of us, doesn't actually look like what it's supposed to be named. So it probably looks rather abstract to many people, but we should be able to get it. So we're starting to get it there, and kind of those star streaks that you can see is caused because we're taking a photograph while the telescope is moving. So sometimes we might get these stars to look like these types of streaks. That's kind of what's happening here. But as we get forward, we can start to see in those darker patches of this nebula. So if you can see a lot of that blue stuff, kind of look in the center and you'll start to see the shape of hopefully a running man. He's kind of like running up towards the left side of the photograph, if you can kind of imagine that, and his arms are like outstretched up over his head. It is kind of an abstract view of a running man, but I think it's kind of a funny one to look at, and oftentimes not one that's often thought of with the Orion Nebula. So that's kind of a fun one to look at. It looks like we have a request for the Sculptor Galaxy, so we can go ahead and head there. We also had a request for Mercury. Unfortunately, Mercury is not up right now, so we will not be able to look at that. So while we head to the Sculptor, this is another really cool galaxy to look at. And it's a pretty big galaxy as well, so we can get a lot of the detail in this galaxy, which is really cool for us to see. So we'll start to get that image in. This one's close to some of the other galaxies we looked at earlier, and the Sculptor Galaxy is in the constellation Sculptor. So this one's super cool. This already looks like a fantastic image, but we can start to see that nice galactic center, that orangish area, and we can also see some really great detail with those dust lanes. Now, the thing I really like about this galaxy is we kind of get 2 points of view in one. We can start to get a little bit of that edge-on view where we can really understand how thin galaxies are in the night sky, but we can also kind of look out across the galaxy, so we can also, at the same time, get a point of view for how wide these galaxies are as well, which is kind of cool. I really like to look at those dust lanes towards the center. There's just so much material going on in these galaxies, so it's always a fun one to look at. Let's see. So Ceres is up right now, but it will look like a dot similar to Pluto. So we won't really be able to see which one is Ceres. It'll kind of blend in with the background stars around it. So I don't know if that is exactly the view we're looking for tonight. So it'll be kind of hard to understand which one is Ceres. I wouldn't be able to exactly point it out for you guys out there. Let's see. So the 4942 Monroe is too faint for us to get tonight. Someone again asked if Pluto is ever visible. Yes, it is. It is visible sometimes, but the only thing is it's so small and faint and billions of miles away that it's really hard for us to get. So if we were to take an image of it, it would look just like a tiny little dot in the night sky, and we wouldn't really be able to pick it out exactly from all of the background stars. So it'll be kind of hard for us to do that. We have a request for any globular clusters. I believe perhaps M15 is up. If we could check on that at some point. I believe we're trying to get another object coming up here. So what we're doing right now is what you can see on the screen is we're putting in coordinates for a specific object. Sometimes our plane wave software doesn't have exactly what we need, so we put in coordinates instead, and it can give us the exact location if that object happens to not be on our search software, basically. So that's what we were doing there. And it's kind of fun to see on the side what we're doing. So we have people up at our Giovale Open Deck Observatory right now helping me with the live stream. So they were the ones taking all the images, and I'm kind of relaying that information to you. So that's kind of some of the behind the scenes things that are happening right now. So what we're doing is that we're increasing the gain or the sensitivity of the camera that we're using. So we're really doing live imaging for you guys right now, which is kind of a fun thing to watch. If you've never experienced something like this before. So it looks like we have lots of more requests. Let's see, gotta go back up. It looks like we have IC59, that's a nebula, and it's probably too faint for us to see. Again, the moon is rather bright tonight, so we have to be careful with some of those fainter objects. And with these fainter objects, we usually have to take a longer exposure. And we want to try to get to as many objects as possible in one night. So we're trying to keep the exposure times to around 20 seconds at most. It looks like we have a request for the Andromeda Galaxy. I believe we can do that. Let's see. Should be up all right. So we're going to go ahead and head there at some point. So the Andromeda Galaxy is the closest galaxy to us at about 2.5 million light years away. So compared to some of the other galaxies we looked at, which were about 45 million light years away, this is relatively close to us. The Andromeda Galaxy is pretty cool because it is ever so slowly, well, I guess not so slowly in galactic terms, but it is coming towards us and is going to collide with our own galaxy, the Milky Way, in about 4.5 billion years. Now, I use the term collide very gently because space is so empty and vast, even within galaxies, that as these two galaxies start to merge together, there's so much empty space that there won't be any star smashing or like planets colliding into each other just because there is plenty of space to be utilized. So that's kind of what we're doing here. So we can start to see that nice galactic center. It's extremely bright. The Andromeda Galaxy is also visible to the naked eye. So that's why it's so bright for us. And when we take an image of it, we get a lot of that light coming towards us. The Andromeda Galaxy is a little bit bigger than our own Milky Way and has about 1 trillion stars in it, which is quite a lot. We can start to see a little bit of that shadow of some of the dust lanes kind of on the outer edge. There we go, that looks awesome. So we can see on that edge, there's a little bit of that dust lane type structure there, which is really fun to see. That's a good one. Let's see. We have lots of requests, so I'm trying to get through all of them without missing any. I think we had a request for a globular cluster, and if we could try M15, if it's up enough, we could probably get that. I don't want to miss out on a globular cluster. They're some of my favorite things to look at. So we're going to go ahead and head over there, and because these objects are so bright, we won't need a super long exposure. So we're going to lower that down now. So globular clusters are quite different from open clusters because all of these stars are gravitationally bound to each other. And for M15 in particular, there's about 500,000 stars or so within this cluster, which is an amazing amount of stars to think about, all in this one tiny little place. And with M15, in fact, we believe that there is a black hole at the center of this globular cluster as a gravitational center of mass. So we can't see the black hole, but we know it's there based off of the gravitational interactions that are happening with the black holes and the stars and material around it. So that's kind of how we can know that it's there. But M15 is also known as the Great Pegasus Cluster. It's just off of the head of the constellation Pegasus. And this is just such an awesome one to look at. Globular clusters are my favorite. I've heard people guess when they come up here and look through telescopes, they describe this as like a frozen firework or like water drops on like a spider's web or something like that. And I always like hearing what other people come up with and what this looks like to them. So I'm always happy to hear about that. Let's see. We have a question of is Polaris visible? So Polaris is not visible to the point of view of our telescopes on the deck. So how the deck works, you probably saw in the introductory video, is that the whole entire building rolls back, which means that towards the north, there are parts of the sky that are blocked by the building. And where our plane wave telescopes are, we won't really be able to see it over the building. So it looks like we already looked at M31 or the Andromeda, so we got that one good. We had another question of a supernova remnant. So we were able to look at the Crab Nebula earlier, which is a supernova remnant. So after the live stream is over, it'll be uploaded to YouTube and you can go back and look at the Crab Nebula, which is a really awesome supernova remnant. Let's see. Looking back here, so we already looked at Mars tonight. So the tadpole we can't see. We can go to the moon, we can look at the moon now, but just as a forewarning, we cannot see the moon rover. We'd need a telescope that is probably miles wide in order to get that type of detail, and we don't have a telescope that is miles wide. So we can get some pretty good detail on the cratering of the moon, but unfortunately we won't be able to see the moon rover. So what we're doing now is we're taking a live video of the moon instead because it is so bright for us. We don't actually need to take a long exposure picture. So this is what we're doing here. It looks like what we're doing is just fine-tuning the movement. So we're going to jog. This is kind of what we call it. We're jogging the telescope just to do some fine-tuning movements to get it a little more centered in the photograph, which is kind of fun to see it move around. So my favorite part of the moon to look at is what we call the terminator line, which is that divide between the light and dark areas of the moon, which I think gives some really cool 3D effects to those craters in that area. So kind of towards the middle top edge of this image, we can see that terminator line. Again, it lends a really cool 3D effect. We get some cool shadows going on with those craters. I think it's kind of an interesting way to look at the moon, something that you don't often think about. So if we overexpose it a little bit, we can see those shadows in a little bit of a different way. You can start to see that. That's really cool. So the moon is always awesome to look at. And those darker areas on the moon are caused by frozen lava lakes, ancient frozen lava lakes. So they're very smooth compared to the other regions around it. And we actually, with the Apollo 11 moon landing, we landed in one of those darker areas. We call them mariae, or seas. And because they're so smooth, it's a little bit easier to land in those areas. So that's kind of what we did. So we had another request for Venus. Unfortunately, we can't see that. It is up during the daytime, however. I think we can try IC418. It looks like we should be able to do that. So we can try that one. And it looks like we have an immense amount of requests. So we will be ending this live stream at about 8:30 just because our telescope controllers up at our Godot deck are in the freezing cold right now, and we don't want them to stay out too long because their hands will probably be frozen already by now. So I want you to keep in mind all of the stuff that you are requesting at the moment, because we'll have another one of these again for the next week. So if you have requests that we aren't able to get to tonight, we can always come back to them. I think we're going to try scroll up, IC418. I am not sure what this object is. I'm not super familiar with the IC catalog, but we can explore together. So we can do that. Let's see. So we'll see if it's too faint, and we'll try to get a pretty good image of this. But we'll probably be able to get to about one more object after this, and then I'll have to call it a night just because we do have people out in the cold right now and we don't want them to stay there for a long time. So again, I mentioned that we are doing interactive stargazing once a week. We will be taking a break on January 5th, but we're going to continue it in the New Year's. So there's lots of new people tonight, which is super exciting. We want to be able to get to your objects at some point, so keep them in mind and we'll be able to get to them at some other point in the live stream. So it looks like the object IC418 is that center object. I'm not entirely sure what it is, however. Let me scroll down. It's a planetary nebula. Okay, and it's about 3,400 light years away. So I've never heard of this object before, so I wasn't entirely sure. I had to do a quick check. Planetary nebulas are super cool to look at, so that was kind of a fun one. We have a request for Betelgeuse. So let's go ahead and do that one as our final request tonight. So again, if we weren't able to get to your object, we'll be able to get to it another night. So keep them in mind. We'd be happy to see you in another one of our live streams coming up, but we are taking a break on January 5th. So just want to mention that. There we go. So Betelgeuse is an amazingly red star in the night sky, and it's so beautifully, if you can go up and look towards the constellation of Orion, it is the shoulder of Orion. It's kind of on the left side. And it is a very, very red star. It is a red giant star. So Betelgeuse is kind of interesting because this past year, in around February times, Betelgeuse was dimming quite a bit, which was really interesting to us because we didn't exactly know what was going on. We actually thought that, hey, perhaps Betelgeuse might explode in a supernova, which it will do at some point, but we don't exactly know when. But what we think happened is that a gas cloud passed in front of Betelgeuse, making it dim significantly. But eventually we were able to figure out that it was just kind of a gas cloud coming off from Betelgeuse and making it appear dimmer in the night sky. But Betelgeuse is one of the prettiest stars to look at, and I think it's a fantastic object to end on. So again, if we weren't able to get to you tonight, please keep your objects in mind, and we'd be happy to see you in another one of our live streams. You can subscribe to the Lowell Observatory YouTube channel so that you don't miss out on any of our other live streams. And because we weren't able to see Jupiter and Saturn tonight, we did a live stream yesterday on the conjunction. If you want to check that out, there's some pretty cool information on that from a bunch of our Lowell astronomers, some history, and also some awesome imaging. So that sounds super cool. And again, we're taking a break next week on January 5th. So we won't be doing the live stream next week, but we'll hopefully be continuing it afterwards. So thank you guys so much for joining us tonight for the interactive stargazing. I hope you had a lot of fun, and please join us next time, and thank you so much.